Hi, and welcome to this presentation on the top 10 secrets of successful Oracle ADF projects. My name is Sten Vesterli, and I've been working with Oracle technology for a long time as a developer, consultant, and trainer. I'm an Oracle ACE director. I have an ADF certification, and I've written a couple of books on Oracle ADF. The one that's most relevant for the content of this presentation is Oracle ADF Enterprise Application Development Made Simple. That book is more about the procedures, the structure around ADF development more than the actual technical aspects. So that's the one that's most relevant to this presentation. I have worked on a lot of ADF projects. In some that didn't go so well, and some that went very well. So from these, I have gathered up the following top 10 tips of good ADF projects. So we'll start out with this brief overview. 1, the catalog, the component catalog, the list of components that you're allowed to use in the project. You need to limit those to prevent your developers going overboard with all of the fancy features available in ADF. Number 2, promises. Expectation management is important in all kinds of projects, and with the power that we're getting with ADF, it becomes especially relevant. Number 3, the proof of concept. At this time, many ADF projects are the first ones with this technology. If this is your first project with Oracle ADF, you definitely need to create a proof of concept. Number 4, package. You need to distribute your application, cut up your application, decide on an application architecture, package up the individual parts, and put them together into your final enterprise application. There's a lot of power in ADF libraries and ADF feature that we'll talk about. Number 5, extend. There are some specific extension points in ADF, and you want to make use of those. It is so that if you do that up front, if you make room for your own extensions of the ADF framework at the beginning, then it becomes easy for you to customize the way ADF works later. But if you don't do this up front, you will have to retrofit a lot of task flows, a lot of pages, a lot of code if you decide on some global change that you need to the way ADF works. So use the extension points. Number 6, a wiki. It's something that has to do with starting with a new technology mainly, but development guidelines. You need development guidelines to make sure that everybody's on the same page, everybody's developing in the same way. And if you write a Word document, nobody reads it. If you are new to the technology, then you definitely need something that makes it easy to share experiences, to share best practice. And I found that a wiki is a good way of doing that. Number 7, the Nutcracker. You need to have an expert to make sure that you're using the ADF framework the way it's supposed to be used. You need somebody with ADF skills, or at least access to somebody with ADF skills that you can ask in order to use the framework effectively. Number 8, version control. It really shouldn't be necessary at this day and age to tell people to use version control, but in some organizations, especially organizations coming from Oracle Forms, they have managed without version control so far. Because an Oracle Forms application consists of a limited number of these very big FMB files that contain business logic and user interface all in one bundle. You might have been able to get along without version control, but ADF is based on a number of artifacts, a lot of XML and Java files, and unless you start using version control, you're setting yourself up for failure. Number 9, build. You definitely need a build tool that also comes or is related to the last point, that an ADF application consists of a lot of moving parts, and you need to make sure that you are building your ADF application in a consistent and automated way. And number 10, logging. ADF has some very good logging features, so you should definitely use those and not just sprinkle your code full of system out print statements. The first tip is to create a component catalog, a list of approved components that your developers are allowed to use. There are more than 150 ADF components, and many of them exist in different variations. So you can build a lot of different user interfaces with ADF. Unless you create a common component catalog, each developer is likely to run off on his own and choose whatever component that he or she feels fits the task best. That makes for a poor user experience once the whole application is put together. What you want is a unified appearance across the whole application, which means that you need to limit your developers to a specific set of components. So include which components are allowed and also the properties and variations that you need to set. Some have various visual attributes, and you need to specify in your component catalog that whenever we use a date field, we set it for a specific width or with a specific format, or when we're using a text area, it should look like this, or our buttons has this width. Whatever is part of your user interface guidelines, it has to be implemented in practice as part of your component catalog. And then once you have that, you can, of course, design all your screens using only the approved components. It is not enough to just have the component guidelines. You also need some visual guidelines on how to use the components. On a project, we had specified that we would use a file upload component for file upload at various places in the application. But the file upload component itself, while we were using that, we were using it in different ways. We were using it inline, we were using it in pop-up dialogues, and we had simply not specified enough detail around the component, how it was supposed to be used. So also set down guidelines for how should dialogues be used and how should your components in general be used. It is possible, because your user interface page is an XML file, to actually produce automated validation. You can actually run some XSLT or some XQuery on your pages to see whether unapproved components have been used. That's not part of the auditing features in JDeveloper right now, but you could implement that if you want to make absolutely sure that nobody has used any unapproved components. The next step is the promises you make, or the expectation management. What sometimes happens in ADF projects, if your developers come from a more limiting development tool and they're suddenly given this very powerful ADF tool, where you can do anything that you put your mind to, what sometimes happens is that developers fall in love with all of the capabilities and they promise too much to the users. What happens in real life is that there are some limitations. ADF uses JavaScript extensively, and sometimes you do run into issues in various browsers. Internet Explorer is notorious for its JavaScript implementation, and we've often experienced things that didn't look quite right in Internet Explorer that looked fine in Firefox and Google Chrome. You need to specify upfront as part of your agreement with the users and the agreement with the test team which browsers and versions you will test on. I've been on a project where all developers were using Firefox or Google Chrome, but the test team was using Internet Explorer. That meant that we're sending screens off to test that worked fine for us. But as soon as they hit the test team started logging bugs against it because they were running Internet Explorer, they were running a different browser. Specify the browser and version that is your reference so that your developers can use that, or at least they can test their screens against that browser and version before releasing code. They don't have to run Internet Explorer day in and day out if they hate it, but they do need to test their screens in the reference browser before submitting anything for test. What you should also do is you should specify the basic functionality. Some of the ADF components have a lot of power, like putting a table inside a panel collection will simply automatically give the user the capability to select columns and to choose which columns you want to display in your panel. But if you start specifying in minute detail exactly how the ADF components work, then you might end up in a situation where the users want to change slightly how the component works. And what happens in a component-based architecture like ADF is as long as it's a feature that the component offers, it is basically free. Oracle has built it for you and made it available to you. But if you want to build your own component to do something that's almost the same but not quite, then you are facing a dramatically increased development time. Some of the things, like you can drop a functionality and operation on a screen to export something to Excel. That takes the developer 5 minutes to drop that button. But if the users want to specify some variation of export to Excel, that means that you have to code it yourself. You're going from a 5-minute task to a task of several weeks. So be careful what you promise and don't specify in detail the ADF functionality. Also, make sure that you and your users have a common understanding of what you are delivering, whether you are delivering a classic web application, a classic page-by-page application, or whether you are developing a modern rich internet application that does partial page rendering where only part of the page changes. If you look at modern web applications, like for instance Facebook, you will see that it does not repaint the whole screen when you interact with it. It's using JavaScript and dynamic HTML to only repaint the parts of the screen where a change happens. If your users are looking for a more page-by-page approach, then if you give them something that is based on page fragments that does partial page rendering, and they were looking for something that was page-based, you have a problem because it's an architectural decision made early in the project whether to use pages or page fragments. And the typical point where this issue comes up is if the user is expecting a page-by-page application, then the user is expecting to be able to use the back button to go to the previous page. Now that works in a page-based application, but it does not work if your application is based on page fragments and partial page rendering. You'll also, of course, run into the issue that it will be reported to you as a bug if the browser security settings disallows, for instance, file download. So there are some things that you need to specify up front, some browser settings that you need to make sure, because you need to make sure are set right. Because a rich internet application, it feels like a desktop application, but it is still limited by browser security. So you might have limitations on cross-site scripting. You might have limitations on file download, and you need to make sure that you have the browser setting. You've specified the browser settings up front. The third tip is the proof of concept. You need to build a proof of concept before you start the real development work on your ADF application. This is especially important if this is the first ADF application that you're building. You need to make sure that you have your proof of concept as a separate pre-project, because your proof of concept, which is done at the time when you are new to the technology, is likely to overrun its allotted time. If you place the proof of concept as part of your main project plan, that means if the proof of concept overruns by a week, you are going to have 6 months of development where you will be running after the development plan, trying to catch up this 1 week delay that came from the proof of concept. So complete the proof of concept before you start the actual development work. In that way, you won't have any delays from the proof of concept chasing you for months and months. If you are building an application that is using ADF in the easiest way, based on relational tables, ADF business components, and ADF faces, you don't have many challenges. Your proof of concept should be easy to build. You might only have some specific user interface elements that you want to use that you have to test out to make sure that you understand how they work. But if you have guidelines for data access specifying, for instance, that you have to use web services for updates, or that you're not allowed to insert into tables, but you need to call a PL SQL API package instead, that is stuff that you definitely need to figure out how to do in the proof of concept. You need to make sure that you've got all the tricky parts covered. And of course, your proof of concept application should also be packaged and deployed to a separate test server. It should not just run on the developer workstation. Make sure that you understand what is involved in deploying the application on a real server, so that you have that solved and you're not standing there before your first milestone and finding out that there is some kind of critical path of the deployment that you don't really know how to do. Another advantage of deploying the proof of concept to a separate server is, of course, that because it's a web application, any stakeholder in the project can just point his or her browser to this test server and see the proof of concept and play around with the code, in which allows you to get some feedback from the users on whether what you're developing is in line with what they're expecting. Also, building a proof of concept does allow you to get an idea of your skill level versus the task at hand. So when you're doing tutorials, everything is simple because you have an instruction to build, an exact instruction to follow to build an application. Once you start with a proof of concept, you're going to hit the real life limitations, the places where you might not know enough. And by building a proof of concept, you get an idea of whether you need a bit of additional training, whether you need somebody experienced on your team or just to have somebody on call, so you know what kind of support you will need in your project. The fourth tip is to package your application correctly. When you are building an application, if you have a small application, you can just put everything into one application workspace in JDeveloper. That is the simple architecture. But for most applications of a realistic real-life size, you will need to decide on an architecture that allows you to have a larger development team work on various parts of the application in parallel. If you put everything in one workspace, as you see in the tutorials that are available from Oracle and elsewhere, you will find that developers tend to get in each other's way. There are some files that tend to run hot that will be used or modified by many developers. The data binding CPX file is classically a problem. And to avoid this, this competition or contest for specific key files, you want to split up your applications in a number of subsystems. For most applications, a modular architecture that uses a common workspace with a couple of projects for common stuff that will be used throughout the application, then a number of subsystem workspaces for various logical groups of functionality, and then one master workspace. That will work well. The modular architecture will work well for most applications. If you are building many ADF applications inside your organization, you might decide on the enterprise architecture instead. In the enterprise architecture, you have two levels of common code or common elements. One is the enterprise common elements that will be stuff that will apply to any ADF application that the enterprise builds. Extending that will be a number of application common workspaces, and each of these will be specific for one application, and that is where you place the changes or the common code, the foundation changes that are different for that specific application. So you have one enterprise common workspace, you have a number of application common workspaces, one for each major application. Inside the applications, you then have subsystems in the same way as in the modular architecture. The enterprise architecture, in the enterprise architecture, you sometimes need to build several different applications, and ADF allows you to use these subsystems in a number of master applications. So you can take one subsystem and use in several different master applications. Technically, the way this works is you would use or create separate workspaces in JDeveloper. JDeveloper likes to use the term application for a workspace, but that's not really a good term, because most applications will consist of many workspaces. So think of them as workspaces instead of applications. You will have a number of workspaces in JDeveloper, and inside those you will have a number of projects. In the common workspace, you will have a common code project, a common UI project that will contain your page templates, etc. And you will have a common model project that will contain the business components that are common to your entire application. Typically, your entity objects are common. They're based on top of the relational tables, so they will be common to the whole application. You might also have view objects that are used for lists of values throughout the whole application. They can go in the common model. Then the view objects that contain the specific data that you need on a screen go into the subsystem workspaces, together with the task flows and page fragments that make up that part of the application. Then the subsystem workspaces are then collected, or the output of the subsystem workspaces is collected in the master workspace that imports all of the subsystems. And the master workspace has menu functionality, it has the security, and then it simply uses the subsystem workspaces that are published as ADF libraries. ADF Libraries is a very powerful feature that's part of ADF. It allows you to package up a workspace or a project with some metadata that allows JDeveloper to figure out what is actually inside this library. So technically they are jar files, so they're just zipped files containing some XML and Java artifacts. But because they have additional metadata, you can see them inside JDeveloper. You can see which business components are available in a workspace, or which templates, which elements that you can use in your project. So you simply produce these ADF libraries, you place them under version control so that your build configuration manager can decide on the rollout. So the team building, for instance, the common code project or the common code ADF library, they might build new libraries for testing as they're adding features, but you will have the people who are dependent on that library will only use the latest approved version as decided by the build configuration manager. So if you place the actual ADF libraries, the actual jar files under version control, that allows you to have a stable version for everybody else to work on, and at the same time you allow the team to build new versions separately. Tip number 5 is to use the extension capabilities that are built into Oracle ADF. The most important part is that you need to create a space for you to put your own Java code in later in case you need it. What happens when you're using Oracle ADF business components is that at runtime, a Java class is instantiated and runs and does the work for you. If you look at the code that is produced in JDeveloper, when you create a simple business component, you will just find an XML file. The XML file is a definition of the business component, and at runtime, an Oracle supplied Java class will be instantiated, will read the XML file, and will exhibit the behavior that you've configured. If you decide to generate Java, you will see that you will get a specific class that is named after your object, but the simple action of generating the Java class does not change the functionality because there is no new logic there. It just allows you to see what is happening. If you look at the code that gets generated, unless you do something else, it will extend the Oracle supplied classes. So if you decide to generate Java for a tasks entity object, you will find the code that gets generated will extend entity impl, which comes from the Oracle JBO server package, which means that at runtime, your tasks impl class will inherit the functionality of the Oracle JBO server entity impl class. You don't really want that. What you want is to extend your own classes instead of the Oracle supplied classes. There are 8 base classes that are used in ADF business components, and 4 of them are used a lot, and those are the ones that you should extend. So the 3 with def in their name, you don't want to mess with those. They determine how the ADF framework works, and unless you really want to change the underlying structure of ADF, you don't want to mess with those classes. And the entity cache class, it implements the caching that the entity objects are using, and I don't think that there is any reason to believe that we as developers are better at implementing caching than the guys in the Oracle ADF team. But the 4 classes that you do want to extend is the entity impl, the view object impl, which represents a whole view object, the view row impl, which implements a specific row in a result set, and the application module impl. The way you go about this is that you create your own classes that extend the Oracle supplied classes, and then you base your own business components on your own extension class. So instead of basing employees impl directly on Oracle JBO server entity impl, you base it on your own class. So in this example, it's Sten Vesterli demo framework entity impl, which again extends the Oracle supplied class. What you can do is you simply create them empty. You create a class, and the only instruction that you're giving is that you're saying my class is placed in my package. It has the same name, or could have any name, but by convention you have the same name as the Oracle class. So you create your own entity impl class in a package of your choosing, that extends the Oracle version of the same class. And then you instruct JDeveloper every time it generates business components to base it on your class instead of the Oracle supplied class. Then at a later point, if you want, you can go in and override specific methods from that class inside your own entity import. This gives you this space, this level in between your actual implementation, like your entity import class and the Oracle supplied class. So by pushing in this intermediate layer at the beginning of the project where it's easy, you have a place that all of your code will call. So if you want to change ADF, how ADF works, for instance, do logging, or if you want to change the way it accesses the database, you'll have one place to do it. If you do it up front, it's easy, but if you do it later, you will have to retrofit all of your business components to use a new common class. So do this from the beginning. Create your own framework extension classes. ADF also has various templating functionality, and similar to the framework extension classes, create templates up front and base all of your application code on templates. There are page flow templates and there are page and page fragment templates, and you should use both. A page flow template allows you to define, for instance, a common exception handling page, or you could have initializer and finalizer code, but you don't have to put anything into your page flow template. The idea here is just at the beginning of the project, you create a page flow template and you base all of the page flows in your application on that template. It gives you somewhere where you could put your own code later in case you need it. And it does not cost you anything to base your page flows on your own template. So do that from the beginning. Similarly, there are page templates where you can define all of the common boilerplate stuff that goes on your pages, and you then define facets in the page template. The facet is a place where the user of the template can actually place his or her content. You can also define attributes so that you can create several layouts based on the same template, or you have page-specific information placed out in the boilerplate area of the template. So just like page templates, just like page flow templates, every page and every page fragment should be based on a template. So you have somewhere a place where you can put common code in case you find out that you need it. Finally, ADF allows you to build something called declarative components. A declarative component is a way to extend existing components. So you can create a component, a declarative component that consists of one or more ADF components configured in a special way. So you might decide that you have a special input field if you're using like an order number throughout your application, and that's always an 8-digit number. Then if you create a declarative component, an 8-digit declarative component, possibly with some validation. So you take an input field and you add whatever restrictions or validations you want and package that as a declarative component, and then you use that declarative component throughout your application. You have one common place to change it in case you later need to change the functionality or the validation behind that. You can even package several components into one declarative component. So if you have an address block that you'll be using a lot of places in your application, you can create a declarative component that aligns your address lines and your city and your zip code exactly the way you want it, and then use that declarative component throughout your application. Tip number 6 is to create a wiki for sharing information in your development team. If you write a development handbook in some tool like Microsoft Word and you place it on a common network drive somewhere, it will not get read and it will definitely not get updated. What you need to do in all kinds of projects is to create a project wiki, so it's available, so it's a number of web pages run by the Wiki software, so that anybody can go and make changes to the text, so it's always available from any web browser, and anybody can add a new page or change the existing text there as they see fit. Now, this is generally a good idea in any kind of project, but especially if you're starting out on your first ADF project. So if ADF is a new technology to you, then it's especially important that you have some knowledge sharing. And the wiki helps you with that, because whenever you need to solve a specific problem, the first developer who needs to figure out how to do something, like say we need to programmatically delete a record, then if you look at the wiki, the developer will look at the wiki. Do I have a tip on how to do that? No, I don't. Then I'll figure out how to do it, and I will write a wiki page on how do we programmatically delete a record. Then the next developer can look at it, see, this is the way we do it. And if the next developer who comes along has a better way of doing it, that person can add his or her experiences to the wiki, so we can just update it, so you have a living development standard that gets updated with tips and tricks for how to use the tool. And that's especially important if you're new to ADF. Tip number 7 is to assign a person the role of Nutcracker on your team. That person is the person who will be tasked with cracking the hardest nuts, solving the difficult issues the most difficult issues that you meet during your ADF development. Preferably, you should not assign normal development tasks to that person, because there's going to be a lot of tasks where you need to figure out the best way to solve something using the framework the way it's supposed to be used. So if every developer on a team that's new with ADF cracks their own tough problems on their own, they will produce a number of different solutions, and many of these will not really work with the grain of ADF. What happens in ADF, in a flexible framework like ADF, is you can always write code to achieve anything you want. The problem is just that on some projects, we've seen people writing a lot of code actually replicating functionality that's part of ADF. That is both wasteful, you're spending energy up front, and it also makes for bad maintainability of your code. You have a body of code that you have to maintain instead of using the ADF built-in features. So what you should do is to have somebody who is experienced with the tool. You definitely need access to somebody who's experienced with the tool, so you can ask that person, how do we solve this specific development challenge in ADF? And that person, the Nutcracker, will then either know the answer or will research various ways of solving this development task, and will document and distribute the knowledge on this is how we do this. This is the role where you should place your most experienced ADF developer. It might be somebody, might be an external consultant, but your most experienced ADF developer should have this Nutcracker role to ensure that you're using ADF with the grain. You're using ADF the way it's supposed to be used, because that gives you both faster development and better maintainability of your code. Tip number 8 is to use version control. As I mentioned at the beginning, some organizations are still not using version control, and you definitely need to do that once you get started with Oracle ADF, because the amount of artifacts that you have to manage is such that a simple file-based pseudo version control does not work. The two main tools that I see used in ADF projects are Subversion and Git. Subversion is a classic version control system. It's widely used. It's free. It's integrated into JDeveloper. There is a Subversion client that's part of JDeveloper, but if you're running JDeveloper on the 11.1.1 branch, the 11.1.1.6, 11.1.1.7, you might find that there is the Subversion client that's in there is not compatible with the very latest version of the Subversion server software or other Subversion clients. So if you're running JDeveloper, JDeveloper on the 11.1.1 track, then find out which Subversion client version you're running. Typically, it would be something like 1.6, and then stay with other clients that use the 1.6. I was at a project where we were using a Subversion. We were using a higher version of Subversion, so we're using Subversion 1.7. So we had another client, Tortoise SVN, which was a Windows Explorer integrated client that created Subversion 1.7 client libraries. So JDeveloper didn't know that the files were versioned. It was not able to understand it. So we thought, well, we will just version it. We'll just version our projects or commit our changes from Windows Explorer instead of inside JDeveloper. That is not a good idea, because what will happen if you try to do that is that you will forget files. When you're working on a file in ADF, especially when you're working on pages, you will find that there are data bindings, there are other files that get created or updated, and you will forget to add new files if you're trying to do your version control in Windows Explorer. So do use the client that's built into JDeveloper, and if you have an issue with that version not being compatible with your Subversion server, either install another Subversion server, like go back one version, or find out a way to integrate the later Subversion client into JDeveloper. There are ways to do that, but don't try to do your version control outside in the file system outside of JDeveloper. Because of the way ADF works and the many files that get changed, you will run into some problems that you can save yourself from by simply using JDeveloper fully integrated, the Subversion client fully integrated in JDeveloper. If you're not using version control, you're just playing. In later versions of JDeveloper, you also have the option to use Git. Git is a distributed version control system, so it has a different approach from Subversion. You would want, if you haven't been using Git before, you would want to read up a bit on the differences and decide whether you want to go with Git. An advantage of Git is that because it's distributed, every developer has the whole repository on his or her local workstation, which means, of course, that it becomes very fast to commit because you're just committing locally. On the other hand, you will need to push your changes up to some kind of central repository every once in a while so that others can't get access to your code. But that means that you have the option to do a lot of commits as you're working, and then you can just decide which version of the code you want to push up to the central repository. People working directly off the central repository typically don't commit very often, because as soon as you commit, it goes off to the central repository. Having two levels of repository like you have in Git overcomes that problem. It's supported in JDeveloper 11.1.1.6. There were two builds of 11.1.1.6, so you have to have the latest one to have Git support. 11.1.1.7 has Git support, and the 12c has it. The 11.1.2 track of JDeveloper, if you have a project that's on that track, it does not have Git support. So in that case, you'd either have to move up to 12c that we have now, or you will have to run with Subversion. Tip number 9 is to create an automated build process. You should at least have an ant script that builds you a clean database with your test data, build all of your ADF libraries, and the master application. You want to split up your application. If you have anything but a very simple application, you will have several workspaces, and you will need to build ADF libraries, and you need to combine these ADF libraries into your master application. And you don't want to have a developer to have to do that as a manual process. JDeveloper allows you or builds you an ant script that does most of this work for you. So it's a fairly simple task to write an ant script that does all the building of ADF libraries and builds a master application. If you prefer to use Maven to build your application, that's also possible in JDeveloper 12c. And in all kinds of projects, it's a good idea to have a continuous integration tool like Hudson or Jenkins, something that will build your whole process and possibly run some tests on it on a regular schedule. It means that you will quickly find out, for instance, if somebody has checked in something that doesn't work, because you would be running a build. You can trigger an automated compile, an automated build of the whole system after every check-in to a central repository, and you can run your tests overnight. So you will get a much better quality of your code, and you will get feedback faster. Tip number 10 is to use the logging features that are built into ADF. You should use the ADF logger class. So you simply instantiate an ADF logger inside every piece of code you have, and then you use the logger that you created to write all your log statements. The idea or the benefit from that is that you can configure ADF logging as your application runs in the logging XML file. So you can do that in JDeveloper in a GUI for the built-in WebLogic server, or in Enterprise Manager, your operations people has a GUI for editing the logging XML file. That allows you to change the log level at runtime. So that means that even in production code, if you need a trace, if you have a hard to find problem that only occurs in production, you don't have to redeploy new code. You can simply set the log level higher, and then you can get a detailed view of what your code does if you're instrumenting it properly with ADF logging. So those were the top 10 secrets for running a successful Oracle ADF project. Number 1, create a component catalog. Use only approved component. Number 2, beware of what you promise. Practice good expectation management. Make sure you're on the same page as your user. Number 3, create a proof of concept, especially if you have something tricky like web services or PL SQL APIs. Number 4, package your application, distribute it or divide it up into subsystems, and use ADF libraries to package everything together and put it into one master application. Number 5, use the extension points that ADF offers. So that is framework extension classes for your business components and templates for your page flows and pages and page fragments. Number 6, use a wiki for sharing information. Number 7, assign a Nutcracker to make sure that you have the best ADF skill available to figure out how to use ADF to solve your toughest development challenges. Number 8, use version control, Subversion or Git. Number 9, create an automated build process. And number 10, use the ADF logging facilities. And if you're just starting out with ADF, you definitely want to get some help. Get someone to help you get started. It's ideal if you can find somebody that will come with you and work with you on site, but it's also possible that you can find somebody that can do remote mentoring for you that you can ask questions to and get some answers from. I'd encourage you to join the ADF Enterprise Methodology Group. You can just Google ADF EMG. That's a place to discuss ADF architecture, not so much the technical nuts and bolts, but more best practice for ADF development. If you're interested, you can follow me on Twitter at ADF Mastery or Sten Vesterli. I have a website on ADF at adfmastery.com. I have a blog, and you're always welcome to send me an email if you have ADF questions. Thank you for your attention.